Good morning, Group 1. Sorry I couldn't be with you today. I'm doing a training course, but I've recorded this video just because I know you don't want to go a whole week without hearing my voice. That would upset you. So I'm just going to guide you through what you need to do this morning. First thing we'll be working on this morning is Unit 6, Software Design and Development. Going to be looking now at Assignment 3, the last assignment for this unit. If you get yourselves onto the Unit 6 area on the hub, a few of the resources I'm just going to talk you through. So to start with, you've got the Assignment 3 brief, which is on here. We'll look through that in just a moment or two. And then you've got a load of resources that relate to Assignment 3. So we've got the Assignment 3 presentation, which I'm going to take you through in a moment. You've got a requirement specification template. You're going to use this for Task A. As you can see, that's part of the Task A resources. This is the template to use to make sure you get all the correct information in your requirements template. It's very basically formatted, but you can change the formats at the end, make it look nice and presentable. There's a couple other things here, some stuff about abstraction. This came from the Principles of Computer Science unit that you were doing earlier in the year, and I'll tell you in a moment how that fits in with your assignment. And then you've got the file here about how to do a Gantt chart. Again, that's from earlier in the year from the SAD unit, and I'll show you how that's useful. Then you've got Task B and a load of resources that relate to Task B. I'll explain those shortly. So for today's lesson, between 9:15 and 12:15, you need to complete Tasks A and B. This is the presentation that relates to Assignment 3. First of all, the criteria for Assignment 3, there's only 3 criteria in it. It's P6, which is about using appropriate tools to design a solution to a defined requirement. That is Task A and B in the assignment. Then you've got M2, you've got to justify the choice of data types in your designs. That's Task C. And then finally you've got D2, which is develop algorithms to represent a design solution. So that is creating a pseudocode design for your program. That's Task D. Basically, this assignment is all about actually designing a program. You're not actually going to create the program in this unit, but the assignment 3 is to actually design it. So if you now open up the assignment brief from the hub, and we'll start looking through that. One thing to mention here, that the scenario in this assignment is the same scenario that we'll be using for the next unit, Unit 16, Procedural Programming. That means that you'll be able to use a lot of the evidence in terms of the designs that you've created as part of your Unit 16 assignments as well. In Unit 16, Procedural Programming, you have to design, then you go on to create, test and evaluate a program. So the first part of that unit, where you're designing the program, you can use some of the designs that you've created for this software design development unit. You will notice when you look at the scenario in the assignment brief that it's a similar scenario, something that you've seen before in one of the mock exams that we did in the Principles of Computer Science unit. This is the assignment brief for assignment 6.3. You notice that the issue date is this week and the submission deadline is at the end of the week after next, so the 9th of February. The assignment has 3 criteria, P6, M2 and D2. We've been through those, so let's have a quick look now at the actual assignment scenario. So you're still working for Suffolk Software Solutions, and the manager has been very pleased with the work you've done so far. You've been creating, in the previous assignments, creating training materials. They're very pleased with what you've done so far, so now they've decided to assign you a client and a project that you're going to work on. You're going to be taking charge of the design stage of this project. The requirements gathering stage has already been completed, so someone from your company has met with the client and discussed what they actually want. The client is called Turf World. It's a company that sells garden turf. They get a lot of inquiries from customers asking them how much it's going to be to turf their garden. So they want a simple program that's going to basically calculate the cost of an order. To begin with, they would just like a basic prototype that they can trial. It's going to be a simple text-based menu system. They're going to run this text-based system for a little while, see how it works out, and then they'll decide whether or not they're going to proceed and have a fully fledged mobile app created with a graphical user interface and so on. So the requirements for this basic prototype are that the customer can choose which measurements they want to use, so whether they're going to use meters or feet. Once they've chosen which measurement unit they're using, they should also be able to enter the length and the width of their lawn. The customer can choose from 3 types of turf. So they've got standard garden turf, which costs £2.20 per square metre. They've got Premier Garden Turf, which is £2.80 per square metre. Or they've got Sports Turf, which is £3.50 a square metre. So the program must be able to calculate the area of the garden in square metres. The program must round the area of the garden upwards to the nearest square metre. So for example, if it was 1.2 square metres, they would round that up to 2 metres, not rounding down, always rounding up. They want to quote for slightly more turf than the customer will need, rather than ever quoting for slightly less. So if the customer requires more than 20 metres or square metres of turf, they're entitled to a 10% discount. So the program must calculate the total cost of the turf that's required. The program must also display an itemized bill showing the area of turf that's required, the price before any discounts are applied, and then the final price if the customer was entitled to the 10% discount. So task A of the assignment, what do you actually need to do? You've got to create a requirement specification. The first 3 sections are going to be inputs, outputs and processing. So you've done some very similar activities to this on the Principles of Computer Science. It was all about the abstraction techniques. I've put a load of resources from back in September in the Task A section, so you can remember you did things like Peter's Party Pantry, where you had to describe the inputs, outputs and processing of Peter's cupcake business. You did Camilla's Sports Location app, where you had to identify the inputs, outputs, processing of the app for telling people about sporting events in their local area. You did Jamie's Supporters Club, Norwich City Supporters Club app, and you did one for Zana's weblog processing app. So you've done this lots of times before, looking through a scenario, identifying what all the inputs will be, what the outputs will be, and then what the processing needs to take place to get you from the inputs to the outputs. When you put this into your requirement specification, make sure for the inputs you record the name of the input, so choose a suitable kind of variable name, a brief description, what the purpose of this input is going to be, and then what you would imagine the data type will be. So for example, if I had a program where a user was going to enter their date of birth, the name of the input would be date of birth. Brief description would be to say that this is the person's date of birth, to make sure that they are of the right age to be using the app, or whatever the purpose is of entering their date of birth, and the data type will be a date and time. Okay, exactly the same thing applies to outputs, so it will be just a list of different outputs with, again, the name of the output, a brief description of it, and what data type it will be. Then you've also got to include a list of what processing or processes will take place. Think in terms of any validation of the inputs. So, for example, if one of your inputs is a date of birth, you might say that the date of birth has to be validated, i.e. that it's a date that is in the past. We can't have anybody joining this app that hasn't been born yet. If you were inputting, say, I don't know, some measurements or quantities for an order, you'd perhaps want to validate them to make sure that they were greater than 0, because you can't order nothing. You can't have a size that's a minor size or whatever. So that's validation. Think about what validation processes will take place. Think about the calculations. So in terms of any calculations that are going to take place, so how do you have you got to work out any areas or final costs or staff wages, any of these kind of calculations or sums, and again just list what calculations are that are being done. And then finally, is there any formatting needed for the output? So are you going to have to display things in pounds and pence, or are they going to need to be displayed with decimals or pound signs, or units of time or weight or area or length, meters squared, for example? So that's the processing, a list of all the processing that goes on, whether it's validation, whether it's calculations, or whether it's just about formatting the outputs. The next part of Task A, your requirement specification, is a user interface. You've got to design two interfaces: a design for the menu screen and a design for the output, which is the invoice screen. Remember, these are text-based interfaces, so it's a text-based menu and a text-based invoice or receipt. There are some examples on the next slide, which we'll have a look at in a moment. Then finally, you've got to do the constraints of the program. What hardware platform you're going to use, and you've got to talk about timescales. So the best way to do that would be to create a Gantt chart. There's the Gantt chart resource on the hub, which is a little bit of a reminder, but you've created Gantt charts before. This part, the constraints, is very straightforward. In the first part, all you've got to do is say what hardware platform you're going to be using. It's a very basic, just a sentence or two that just says you're going to be using a kind of standard PC. Doesn't need to have any particularly fancy specification, just a PC that's capable of running a basic Python program. With that, obviously, you'll have a monitor, keyboard, and just the basic peripheral devices. That's all that needs to be, a couple of sentences just saying what hardware platform you're going to run the program on. And then you're going to create a Gantt chart showing the development time scales. So this very similar to what you did in the systems analysis and design, where you've created Gantt charts for that project. You just need to say, make up some dates and how long each phase will take. So you've got your requirement specification, you've then got the designs, you've got the coding, the testing, the evaluation and maintenance. So just put all those stages into a Gantt chart and obviously give appropriate timescales for them. That's everything you need to do for the constraints section. So now open up the requirement specification template and let's have a quick look at that. So here it is, the Turf World requirement specification. You can obviously format this once you've finished it, make it look a lot more presentable, but it's just, again, just got each of the sections in it. So here's your inputs, your outputs and your processing. A little reminder of what needs to go into them. Obviously you can delete these red bits at the end. You're then going to have your two interfaces, so you've got a menu screen and an invoice screen to put in. Here you're going to talk about your constraints, so what hardware platform is it going to be used on, and then create your Gantt chart in there. Okay, so once you've completed all these sections, obviously just make the title and the subheadings and everything formatted so it looks a bit more professional. The final thing I just want to look at for Task A is these example interfaces. So here's a couple of examples of text-based menus. Okay, just simply numbered with all the different options, and there's an instruction to choose a number and then press enter or whatever. Here's another example. They've used letters here for the different options this time. You've got X to exit, stuff like that. Okay, so there's two text-based menu systems, and on this side, on the right hand side, we've got two kind of invoices or receipts. So you can see it shows how many things have been ordered. You'll have to do what the size of the garden is and all the measurements they've entered. It's got the kind of subtotals, whether you've got any discounts. Again, this one is showing the overall total and then breaking it down. You've got things like the customer's name, etc., or the name of the company. That just shows you a little bit of an idea of how you might lay out your invoice screen. So Task B, the other part of P6, you need to create some design documents. You've got to design the Turf World program, okay, using at least two of these design tools. You've either got a flowchart, a structure diagram, data flow diagram, or entity relationship diagram. You've seen all these different types of design documents before when you were doing the Systems Analysis and Design unit and in the Principles of Computer Science unit. I've put some of the resources from those units on the hub as a little bit of a reminder. If I was you, and if I was going to do this, I would probably go for a flowchart and a structure diagram. But it's up to you as to which of these you're kind of most happy with doing. I would say definitely do one of the first two, but I would recommend flowchart and structure diagram as the two that you've got to pick. There's an additional video going through structure diagrams, as you're probably not too familiar with those.